Good morning, students. Today we will be doing the first practical for physics, that is verification of Ohm's law. We know that at constant physical conditions like temperature, amount of current flowing through a conductor is directly proportional to potential difference across its ends. So V is equal to IR, and when it is shown graphically, it turns out to be like this for ohmic and non-ohmic conductors. Now, this law was actually given by George Simon Ohm on the basis of an experiment conducted by him. On the basis of the experimental results, he reached to a conclusion that how current varies with the applied potential difference. Now, this we need to do as a part of the syllabus as well, but in the absence of an actual lab setup, we can do so with the available online labs. Today we will be doing exactly the same thing. O-Labs, as we commonly refer to these online labs, gives us an opportunity to conduct several experiments with the help of very good simulators. Now these simulators help us to get a real experience of using different appliances, different instruments that we will be actually using in the lab as well. So that's why these online labs are referred to as virtual labs. So using one such virtual lab today, we will conduct the experiment of verification of Ohm's law. As we all know that for verification of Ohm's law, we need to have a couple of appliances connected in the circuit. And all these appliances will help us to reach to a conclusion as to how current is dependent on applied potential difference. For this, you need to remember the circuit diagram of Ohm's law. In the circuit of Ohm's law verification, an important component is the rheostat, that is a variable resistance. We would be shortly discussing about it, but prior to that, let us see the other components. There is a battery, there is an ammeter and a voltmeter. The ammeter obviously measures the current. Presently it is at 0. The voltmeter has been connected in parallel across a unknown resistance R. Voltmeter, as we all know, is always connected in parallel, and it measures the applied potential difference. Presently the switch is in the off state, so no current is shown by the ammeter, and obviously the potential drop is 0. Now, for conducting this experiment, we need to vary the values for current and potential difference. For doing so, we require a rheostat. As I told you, it is a variable resistance. You can see I am moving the wiper or the slider. Now this movement of slider is actually changing the resistance. You can see in the picture that rheostat or the variable resistor has got a coil comprising of finely wound wire. It is so tightly packed, closed wound. So as the wiper is sliding over this wire, actually the resistance is varying. This is the position corresponding to minimum resistance. Now I have pressed the switch on and you can see current started flowing. So let's see what is the measurement done by the ammeter and voltmeter. The potential drop across the resistance is 5 volt. Ammeter has recorded a current of 0.42 ampere. Okay, so this is the current flowing through the ammeter, that is 0.42 ampere, and the potential drop is 5 volt. So we can use it as our first reading, 0.42 ampere, and the voltage is 5 volt. Let us now change the position of the rheostat. Let us move the wiper a little bit towards the right. So this is going to increase the resistance. Increase in resistance has got an inverse effect on current. Obviously the current will be reduced. As you can see, the current recorded in the ammeter is 0.17 ampere. Potential drop is 2 volt. This will be our second reading. Similarly, we can keep on changing the values. Let the third value for potential drop be 3 volt. Accordingly, current is 0.25 ampere. For voltage 4 volt, current is 0.33 ampere. Let us slightly change the value a bit more to obtain different values. See, voltage is 2 volt, current is 0.17 ampere, voltage is 0.12 volt, current is 0.01 ampere. Now this is the position for maximum resistance. See, so the current has reached the minimum value 0.01 ampere. Voltage is 1 volt, current is 0.08 ampere. So in this manner you can see, by simply moving the wiper or the slider of the rheostat, we are changing the values of potential drop and current, and using these values we can reach to a conclusion as to how current flowing in the circuit is varying with respect to the applied potential difference. This is exactly the thing that we will be doing actually in the labs. Let us plot these values. We have maintained an observation table in which I have already written down the values. We had measured 6 values. There is one separate column for resistance as well. So when a graph is plotted between V and I, that is voltage and current, you obtain a straight line passing through the origin. Now in this case, one thing, that is the temperature, all the physical conditions have been maintained to be constant. One thing I must like to tell you, that in this simulator, in the axis for the graph, the interval has not been maintained properly. So we maintain the interval properly when we plot the values in the graph paper, and still it comes out to be a straight line. Okay, it's almost a straight line because it is an ohmic conductor. So thanks for watching.